So the first thing I'm going to do is explain what is merge sort. Merge sort is basically a sorting algorithm that has the time complexity of O of n log n. So it is one of the faster sorting algorithms. Uh, Let us take an array of 8 elements, 2, 4, 3, 1, 6, 7, 0, and 5. Yeah, let's take this as an array, and let's say we want to sort this array. First thing it does is separate this array, split this array into two arrays. Basically, this is one part, this is another part. It separates it 2, 4, 3, and 1, 6, 7, 0, and 5. Now, since this merge sort algorithm is a uses a recursive function, it will once again split these arrays, sub-arrays, into 2, 4, and 3, 1. Similarly, 6, 7, and 0, 5. And again, it splits it into 2, 4, 3, and 1, 6, 7, 0, and 5. These are sub-arrays with each one element. Now it will sort these elements and merge them together. Basically 2 and 4 will be merged together as 2 and 4 only, because it is the same thing. 2 is lesser than 4. 3 and 1 will be merged together as 1, 3. 6 and 7 will be the same, 6 and 7. 0 and 5 will also be the same, 0 and 5. But uh, now in the 2, 4, and 1, 3, it will get merged into 1, 2, 3, and 4, whereas this will get merged into 0, 5, 6, and 7. And finally, it gets merged into 0, 1, 2, 3, 4, 5, 6, and finally 7. But this is how the merge sort algorithm works. And looking at the code, this is the normal merge sort code. We have a function called merge. This basically looks and merges the functions. This part 2 and 4, it will check which one is the lesser number and puts it on the left, which is the greater number and puts it on the right. That is exactly what this function does. So yeah, and then in this merge sort function, this basically splits the function. It basically splits the array like this. As you can see here, it splits them from L to M. M is basically the middle point, and then from the middle to the end. And we go through it. Since it is a recursive function, it will go through it again and again, and then it will finally merge it together. Yeah, this is how the function works. So with sequential, you can see that we have a size of 250,000 um elements in the array. We are opening a file called data.txt. To create data.txt with 250,000 integers, I used a Python code. It is extremely simple. It just opens file using file handling, and then deletes all everything in the file, because if I have to run it again, it just has to do the same thing. And it just writes all the random digits into the data.txt. That's it. Uh, so yeah, now let's try running this. This function is finished, and you can see there's new data here. And let's go to sequential, and let's run this one. You can see it just ran this code with execution time of 0.057 seconds. Sorted sequential, we have the sorted elements of 250,000 elements. As you can see, all the 250,000 elements are here. It is still for 4,99,000, because the random numbers range from 0 to 5 lakhs. So what we are this is the sequential part, but then we are going to be doing it in a parallel way. See, this sequential part, it does it first, splits it one by one. For example, first it goes through here, 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 and then it does this um, it does it sequentially. It does not, it does one by one, each branch one by one. But in sequential, we are able to do it two branches at once. Like first we are taking this branch, we are splitting it, this one and this one, as two, not we are not doing we are doing this two branches at the same time in the parallel sequence. We can do that by importing OpenMP, by including OpenMP. As you can see, the same 250,000 elements. This merge code is also pretty similar to what we have done in the sequential code, but the main change occurs in the, as you can see, we are creating a OpenMP parallel section, and we are parallelly executing both the merge sort functions. Here it is sequential. This happens after this, but in here these both happen at the same time. So similarly, we get we open the file data.txt, we get the file, we uh, uh, merge sort it, and then get the time using openmp underscore get underscore w time function, and then write it to the, this time to the sorted OMP function, or OpenMP basically. I mean, write it to the sorted OMP text file. So to do this, first of all, I need to run this code gcc hyphen fo f openmp par.c. Par.c is the file name. So first I'll just run this code, and then let me start the code. As you can see, it executed it in 0.037 seconds when compared to the 0.57 seconds in the sequential method, which is far lesser than the sequential one. As you can see, sorted OMP 0, 3, 4, 7, 10, 18, and sorted sequential 0, 4, 7, 10, 18, 19. It is basically the same sorted file, but in a lesser time period when compared to sequential. Okay.